Sorting and searching algorithms Part 2. Heap sort algorithm. Heap sort algorithm.
Heap sort is a popular and efficient sorting algorithm in computer programming. Learning how to write the heap sort algorithm requires knowledge of two types of data structures: arrays and trees. For example, the initial set of numbers that we want to sort is stored in an array. After sorting, we get a sorted array. Heap sort works by visualizing the elements of the array as a special kind of complete binary tree called a heap. Note: as a prerequisite, you must know about a complete binary tree and heap data structure.
Relationship between array indexes and tree elements.
A complete binary tree has an interesting property that we can use to find the children and parents of any node. If the index of any element in the array is I, the element in the index 2i plus 1 will become the left child. And element in 2i plus 2 index will become the right child. Also, the parent of any element at index I is given by the lower bound of I minus 1, divided by 2. Let's test it out. Let us also confirm that the rules hold for finding parent of any node. Understanding this mapping of array indexes to tree positions is critical to understanding how the heap data structure works and how it is used to implement heap sort.
What is heap data structure?
Heap is a special tree-based data structure. A binary tree is said to follow a heap data structure if it is a complete binary tree. All nodes in the tree follow the property that they are greater than their children. That is, the largest element is at the root and both its children and smaller than the root and so on. Such a heap is called a max heap. If instead, all nodes are smaller than their children, it is called a min heap. The following example diagram shows max heap and min heap.
How to heapify a tree.
Starting from a complete binary tree, we can modify it to become a max heap by running a function called heapify on all the non-leaf elements of the heap. Since heapify uses recursion, it can be difficult to grasp. So let's first think about how you would heapify a tree with just 3 elements. The example above shows 2 scenarios. One in which the root is the largest element and we don't need to do anything. And another in which the root had a larger element as a child and we needed to swap to maintain max heap property. If you've worked with recursive algorithms before, you've probably identified that this must be the base case. Now let's think of another scenario in which there is more than one level. How to heapify a root element when the top element isn't a max heap but all the subtrees are max heaps. To maintain the max heap property for the entire tree, we will have to keep pushing 2 downwards until it reaches its correct position. Thus, to maintain the max heap property in a tree where both subtrees are max heaps, we need to run heapify on the root element repeatedly until it is larger than its children or it becomes a leaf node. We can combine both these conditions in one heapify function S. This function works for both the base case and for a tree of any size. We can thus move the root element to the correct position to maintain the max heap status for any tree size as long as the subtrees are max heaps.
Build max heap.
To build a max heap from any tree, we can thus start heapifying each subtree from the bottom up and end up with a max heap after the function is applied to all the elements including the root element. In the case of a complete tree, the first index of a non-leaf node is given by n divided by 2 minus 1. All other nodes after that are leaf nodes and thus don't need to be heapified. So, we can build a maximum heap as array I is equal to 6 divided by 2 minus 1 equal to 2. Loop runs from 2 to 0. First, I equal to 2. Heapify array 6, 2. 9 is smaller than 10, so 10 move up. Second, I equal to 1. Heapify array 6, 1. It is already heapified. Finally, I equal to 0. Heapify array 6, 0. 1 is smaller than 12, so 12 move up. One is smaller than 6, so 6 move up. As shown in the above diagram, we start by heapifying the lowest smallest trees and gradually move up until we reach the root element. If you've understood everything till here, congratulations, you are on your way to mastering the heap sort.
Working of heap sort.
Since the tree satisfies max heap property, then the largest item is stored at the root node. Swap. Remove the root element and put at the end of the array, nth position, put the last item of the tree, heap, at the vacant place. Remove. Reduce the size of the heap by 1. Heapify. Heapify the root element again so that we have the highest element at root. The process is repeated until all the items of the list are sorted.
The example of working of heap sort.
The code below shows the operation.